This section is Wireless LAN Overview and looks at the application of wireless LAN within the enterprise. Wireless Local Area Networks, or WLAN, represent a natural evolution of the fixed Ethernet network as a solution to demands for flexible and mobile business environments. WLAN applies radio frequency, or RF technology, to the enterprise Ethernet network and governed primarily by standards defined by the IEEE Standards Organization. A general understanding of WLAN requires a principal knowledge of these standards as well as the benefits that wireless LAN technology brings to the enterprise network. This section provides a brief overview of wireless LAN technology and its application in an enterprise as a considerable solution to providing benefits to an existing enterprise network infrastructure. So upon completion of this section, it is generally expected that trainees will be able to explain the basic application of wireless LAN in the enterprise network, as well as describe the benefits that wireless LAN introduces to the enterprise network. Wireless local area networks represent an overlay of the current enterprise network that allows for mobility within the enterprise that is not supported by the fixed line Ethernet network. While this section does not go into detail of the implementation of wireless LAN, since this represents a technology field of its own, it does highlight the technical standards, application solutions, and considerations of wireless LAN as an extension to the existing enterprise network. In terms of benefits to the enterprise network, the implementation of wireless LAN allows for efficiency in the workplace by supporting a transition from fixed networks to support for mobility for devices such as laptops and tablet devices that allow flexibility of access for non-stationary networkable devices and workers that are constantly on the move. The stages of evolution that have taken place that have led to the growth of wireless LAN within the enterprise initially began with fixed networks that remain the backbone of the enterprise network. However, such networks do not provide the flexibility needed to solely support many of the requirements of the industry. Steps towards wireless networks saw the implementation of standalone access points, or APs, which provided wireless access, however did not provide the level of coverage that would allow for true user mobility. Growth led to the centralized wireless network that introduced a controller, which could manage APs known as thin clients. Along with this was the growth of standards that enabled better throughput of data for supporting ever more services. These standards are represented as part of the 802.11 standards group, involving A, B, G, and N standards, with emerging standards in the form of 802.11ac. As networks continue to evolve, we see the further evolution of the wireless enterprise in general to support BYOD, or Bring Your Own Device solutions, for smart mobile devices. However, along with this, a number of other challenges are faced by the enterprise network, including support for a higher density of devices, as well as ensuring sufficient bandwidth and security for the existing network. As mentioned, a number of standards exist that represent the transmission medium used for wireless communication. 802.11 represents the working group that initially established a standard for wireless transmission at a rate of 2 megabits per second. We will generally find that wireless communication operates in a frequency spectrum of either 2.4 GHz or 5 GHz. For many of the standards, the 2.4 GHz range has been adopted, since it is able to support a greater distance of transmission, however represents a more populated band, and so is unable to support larger transmission rates. It is also susceptible to interference from other devices, such as microwaves and cordless phones. We find, however, that for the newer standards, such as the 802.11n and 802.11ac standards, the 5 GHz spectrum is increasingly supported, in order to accommodate the required spectrum to support the associated data rates. As part of the enterprise network, the wireless LAN is deployed over the existing network infrastructure as a means of extending the capability of the network to provide wireless access to employees and visitors. We demonstrate here how access points are established at the access layer to provide the wireless point of access for wireless-capable end stations. The access controllers used to manage the AP are deployed within the core of the network, using a bypass mode that means the AP can be managed without being directly connected to the access controllers, which allows for the adaptation of the wireless support with minimal changes to the existing physical network architecture. The deployment of wireless access points within the enterprise is performed with the goal of ensuring that coverage is provided throughout the surrounding enterprise building or campus. The deployment of an AP and its supported range can vary based on many factors, including barriers that may cause obstruction or interference to signals, the supported coverage range, and antenna gain, which refers to the power of an antenna and its general ability to direct that power towards a receiver. The overlapping of AP cells allows better coverage for users that may otherwise suffer from weakened signal areas, or even a drop of signal, perhaps due in part to interference from other obstacles as the host moves between cell coverage areas. The host, as a result of overlapping, is more likely to discover a good signal that helps to maintain coverage throughout the enterprise environment. Ineffective AP deployment within such an environment may also result in areas of weak or no coverage, which fails to ensure ubiquity of the signal throughout the enterprise, and therefore such AP deployment must be analyzed to ensure full signal coverage through wireless site survey tools. Wireless signals are also not restricted to the confines of an enterprise, and therefore may extend beyond the walls of the physically secured environment, allowing the potential for non-authorized users to piggyback the connection without entering the actual confines of a building. Administrators therefore must give consideration to the security of the network, both internally and externally, to ensure that the integrity of the enterprise network as a whole is maintained. Security for wireless networks represents a challenge in itself, since an enterprise network may be used to support different personnel, including administrators, employees, and guests, as well as restricting unauthorized users that may attempt to gain access through various means. Such control may involve authentication that determines the users that are trying to access the network and their given level of authorization. In addition, it may be necessary to ensure that the accessing device is inherently secure and not likely to pose a threat to the network through factors such as viruses and known security holes in the system's software. Network Access Control, or NAC, represents a solution for managing entry to the network and its internal resources, that may include corporate resources and other protected data. Access may be authorized through standards such as IEEE 802.1x, implemented as part of the WPA and WPA2 security protocols, that are used to protect networks by maintaining the privacy of data and allowing access by only authorized users. So we come to the summary for this section, just a couple of questions here. The first is, what advantages does a wireless local area network bring to the enterprise? Well, through wireless networks, we are able to expand the overall mobility of users in order to enhance general business efficiency. There is also a greater flexibility to support access to resources and services from anywhere within the enterprise network domain, as well as provide such services to customers and guests. What are some of the major concerns associated with a wireless LAN? Well, as we have seen, the wireless network provides a potential window for unauthorized access if not managed properly. This could come in the form of users attempting to gain unauthorized access, or as a result of rogue wireless devices being inserted into the network. There is also the need to ensure that the wireless service is able to support the needs of its users. Evolving services and a growing number of users means that saturation of bandwidth may occur, which for wireless networks may operate at a rate that is not equal to that supported by the fixed line Ethernet network.